Let us this example 2. It says ABC is a rectangle with AB. I think this is where our AB is 1.5 meters. This is 1.5 meters to that side. And AD is 1 meter. So AD is 1 meter up to there. Okay, then what happens after? Forces 2 newtons act along AB. So 2 newtons. So this is 2 newtons AB. 1 newton BC. 1 newton BC. Then BC 1 newton also. And 3 newtons along AD. 3 newtons. Find the magnitude and direction of a single force that can replace the system of forces. What is that single force? So, at A, you need to get the resultant of the horizontal components and then the vertical forces. So, if I consider the forces in this direction, it means that I will get the horizontal component, which is going to be, you see we have 2, then plus, you see when this one is there. 1. So our x is going to be 3 newtons. Then if I get the multiple components, I have my y equaling 2. My y going up, we have 1 plus also this one, which is 3. So my y here is going to be 4 newtons. So my resultant force, Fr, given by capital Y, which will be 3, 4, this is going to be in newtons. To get the magnitude, you can MB. This is positive and this is positive. So, this is how that force is going to be. Positive 4, then positive 3. And this is going to act as our resultant force. Okay, so it's going to, this is the arrow, we need the direction. This one describes the direction. In forces, we describe direction using this. Don't confuse with that. And I think those things. Okay, anyway, to get this FR, so that our FR is going to be the square root of 4 squared plus 3 squared. Our FR is going to be 5 newtons. So, this is the force that can replace all those forces. Then its angle, its theta, is going to be an inverse. The opposite is the opposite is 4 over adjacent, which is 3. So, our theta, the direction, is going to be 53.13 degrees. So that is the direction, as simple as that. So that's how you handle that, and you are done. So you say the resultant force is 5 newtons acting in the direction of 50 degrees towards towards MB or towards the Newton is force, as simple as that. Okay. Resultant force is 5 newtons acting at 5,313 degrees to the B, as simple as that. Where the line of, and find where the line of action of the resultant cuts AB. So if you need the line of action, it means that we need to get our moments. Because our line of action is given by y minus capital Y small x equaling 0. So it's that we need this. So how many? The first way of getting these resultants, okay, it depends where we are going to take moments from. So let me show you this way, and I'll also show you the other way. So first of all, if I take moments about A and clockwise, we take, because the line in this equation, we took them anti-clockwise. That's why whenever they ask this line of action, take it anti-clockwise. If you are going to use this, if you are going to use the other one, then you can take them clockwise. So My B here is going to be about any force now coming from A is going to be having this moment as 0. So instead we have 2 times 0, then plus 3 times 0. Because these ones don't have perpendicular distances. So remember that we are taking moments at A. Any force that is coming or going away from A, when this initial point or the coming point is to A, it's going to be having 0 as the perpendicular distance. Then plus, you see, this one I'm taking anti-clockwise, so this is going to be 1, then times the perpendicular distance from here up to here is 1.5. You see this one is going to act clockwise. I think we can see this is the force here. From A, you see it's going to act clockwise. So, there I'm going to subtract minus 1 times the perpendicular distance from here to here is 1 meter. And start from there, my D is going to be 1.5 minus 1, 0.5 Newton meter. So that is going to be the moment. Or if you don't want to use this, you can use the idea of the other idea of getting B, where you say that our B is going to be. Now, if we assume that we are taking them at A, we assume that this is the origin. Okay, let me draw it here so that people can able see what I'm talking about. Okay, alternatively, you can get the moments using this idea. Remember, from here up here, there is 1.5 meters. Then also from here up here, there is 1 meter. Remember, this is our A, B, C, D. This one was going this side, this one this side, this one this side. This was 3 newtons, 1 newton, 1 newton, 2 newtons. So now, if this is because we say this method works if we take the moment about the origin. So if I also take moments here, then from here up to here, say I'm adding 1.5. So now this one is going to be, the x is going to be 1.5, then the y is still 0. When I come to this, you start here, the x is the same, so 1.5, but y is on y I'm adding 1. So I'm adding 1 here. Then here, you start the x is the same, so the x here is 0, but the y I'm adding 1, this 1. Then here it's the same. So taking it there, we are going to take it this way. So instead we are taking moments about A, which is the origin 0, 0, anti-clockwise. Okay. So you see, we say we get the coordinates where the force is coming from. So this force is coming from 0, 0. So the force you start horizontal is 2, the vertical is 0. Then plus. This force is coming from 1.5, 0. This is the vertical, means it doesn't have a horizontal. Plus. This force is coming from this one. This is where it's coming. This force is coming from here. So this one becomes 0, 1. Where it comes from. You see it's coming from there. And then this one is going to be you see this is the horizontal component going the other side. So it's 1, 0. Then plus. This one is coming from here. This force is coming from here. So the units there, the coordinate where it's coming from, this is where it comes from. 0, 0. Then you see it has the vertical, the x is 0, then the vertical is 3. Start from there, our key is going to be, this is going to be 0 plus 1.5. This is going to be 0 minus 1, then plus 0. And start there, our key is going to be still 1.5 Newton meter. So those are the 2 ways you can use to get the moment. So I think I can stop at that. Anyway, if I'm down to get now my part B, I will still part B. Remember our E is given by x, y, capital X, capital Y. Remember we got our B as 0.5 equal equaling 2xy. We don't know where this moment is acting. So this is now the x here, the capital X is 3, then this is 4. 0.5 equaling 4x minus the determinant. How do you get the determinant? The product of the major, then minus the product of the minor, which is 3y. Which when you take this side, you have 3y equaling 2. When I take this side, 4x minus 0.5. And that's going to be the line of action. And where the line of action cuts AB, where does it cut AB? So it cuts AB here. At this AB here, any AB here, the y coordinate is 0. So at AB, comma, y is 0. So at AB, y is 0, so we have 3 into 0 equaling 4x minus 0.5. Find that from there our x is going to be 0.5 divided by 4. So your x is going to be 0.125. So that's the point now where the line cuts. So it cuts it at. So the point there, it cuts it at the x 0.125, then the y is 0. So they asked the distance, then the distance, you can get the distance. Where the line, find where the line cuts the action. I mean the line of action of the resultant cuts AB. This is where it cuts AB. Then if you want the distance, we shall just get magnitude of this x, which will be 0.125 meters. So 0.125 meters from A, as simple as that. So once you learn this, if you don't want this, you can ever use this. It's okay. You use one, not two. I will just show you how you can apply both. That's it. I wish you well.